Hello guys, so today's Leetcode question is freedom trial. So this question falls under the category of Leetcode hard, and this question says that a brief introduction about the game Fallout 4 with a machine name called freedom trial ring, and here the ring is representing a particular string and key is also a part of the ring which consists of certain characters from the ring itself, and the first character of the ring is called the 12 o'clock direction, so it is represented in the form of a circle, right? And our task is to find the minimum number of steps to spell the character in the keyword. Okay, so let's quickly hop on to understand the intuition and draw a particular approach while understanding the test cases. Okay, so before going on directly to the intuition, let's also discuss about the constraints. So the first constraint is the length of the ring and key is strictly less than 1 and 100, and ring comma key has lowercase English letters only, and every time it is guaranteed that the key could be spelled by the ring. That means that each and every character in the key is present in the ring, and there is no such character in the key which is not present in the ring, right? So let's simply draw the intuition which is already mentioned in the question and which is so confusing that we can't really judge what's going to happen and what approach to choose, right? So we are given a ring. Okay, so this is a ring and each has some letters A, B, C, so on to some, let's just say some Z, right? If the string or the ring string is equals to A, B, C, so on to Z. So they are represented in a circular fashion. Okay, and this ring has a starting point at 12 o'clock. Okay, and you can either go to the right or you can either go to the left. That means directions can be anti-clockwise or clockwise. Okay, and it is clearly mentioned that each and every step on the left or right side of you will cost you a +1 cost. So cost would be +1 on right hand side, that will be clockwise, or anti-clockwise, which is left hand side, right? And whenever you are taking a particular character on the right hand side or the left hand side, excluding your input, I mean the position where you are standing at, will cost you extra 1. So including character cost is also present. So including character cost is equals to +1, right? So your cost of moving is +1 if you try to move from position 1 to 2. That means if you are moving from A to B, the position cost would be 1 and B to C would be 2. And so from moving from A to C will cost you 2, right? And similarly, moving from A to Z will cost you only 1 because it is only one position away. So this is the advantage of using a cyclic representation, right? Okay, so let's quickly move on to the test cases and just draw the conclusion from the test cases and just quickly back to the intuition also. Okay, so the first test case is given ring is Gaudian and we have a key as GD. Okay, our output is 4. Let's understand how the output is 4. Okay, so let me just draw the actual ring, right? So this would be the ring and we are given Gaudian. So this will be your 12 o'clock. The first character in the ring will be the 12 o'clock, right? So G O D D I N G, right? So this is your circle, right? So it is given differently in the Leetcode example, but still works fine. Okay, because we are only caring about the incrementation with the step. Okay, and your key is GD, right? So your G is at 12 o'clock, fine, and you need to include D, right? Okay, so you are standing at here, you are standing at this position. You can go to this position or this positions, right? Okay, so we have D's at here and D also here. So let me just check. So we are having a D from G at a position 2 on the right hand side. Okay, And similarly, if I'm going anti-clockwise, we are having 1, 2, 3 and 4. And obviously we'll be taking the minimum step, right? So minimum out of these two will be this. Okay, fine, right? So you are including cost of taking a character. As I've already said, if you are including any character, may it be the first character of the key or the last character of the key, will cost you 1, right? So your inclusion of G will cost you +1, and I'm moving right side, right, which is +1. Is it equal? No. Next, +1. Is it equal? Yes, right? You stop it here. And now you are also considering D, which will also call you +1, right? So the total cost would be G's cost, which is +1. Next, path cost, which is +2, and D's cost, which is +1. So the total cost would be 1 plus 2 plus 1. So that will simply equal to 4, right? Right. So similarly to the previous question, here also we try to find the minimum steps, right? So the output is 13. Okay, how? Let's see. So from G, we already know that to include G, the cost will be +1. Okay, so next you need to include O, which is at distance +1. So +1, +1, and you need to include O, which is +1, right? So the cost is 3. And from O to include D, the cost will be what? +2, right? Similarly, to include another D from D, +2, and +2, +2, +2, right? So 3, 2, 2, 2, 2, and so on till here we have 2. So that means you have 5 into 2 plus your 3, right? So the total cost would be 5 into 2 plus 3, that will be costing you 30, right? So this is the test case. Okay, so let's quickly be back onto our intuition. So here I have told you that, okay, so you can move to right or left. Okay, fine. Now while moving right and left, you will check the minimum of these two, right? You will take the minimum of these two. Okay, and will also include the cost of, current character plus destination character, right? So that simply means if you have a key which just says A so on to your Z, so you keep one pointer P at A, the next pointer at here, which say, let's just say it's Q, right? And after including these both, you will increment your starting pointer here and your next pointer here, and so on. You will continue till end of the string, right? So you are moving to your left and right, taking the minimum, and also you will take your result to be minimum, right? So left has some 4 steps and your right has some 3 steps. You will consider the right one, right? And out of these all things, you will take the minimum cost. So let's just consider a test example like this. So here you have your GDX and there is a long string which they say includes the GDX along with some other characters. So if you consider this and if you move in the right and left, the right might give you a solution, but that's not optimal, right? So if you are getting optimal solution, that means that you are checking your both left and right conditions very effectively. But if you only take your minimum path, every time if you only consider your minimum path, that might result into a greedy approach, right? So every time you're greedy will give you a wrong answer for longer test cases, right? So I suggest you to take the dynamic programming over the greedy, not greedy DP, but a optimal DP, right? So we will code our approach into the optimal DP. So we'll just try to code our intuition. starting from some base test cases, and then we'll move on to the code. Okay, so let's discuss our approach. So as I've already told you, we'll be jumping on to dynamic programming, right? So why dynamic programming? Because we are having a continuous check on the minimum value, well, from the left anti-clockwise side and the right clockwise side, right? Okay, so this, if I discuss from recursion and backtracking, this will be a very long video, so I want to keep it short. So let's just quickly hop onto the top-down approach, or let's just say optimized bottom-up approach, right? So let me write down the code for the bottom-up approach, right? So here we'll take a DP table, which is a very two-dimensional DP table, right? Okay, so here it consists of all the characters of key, and here we have ring, right? So this particular index tells us that to arrive at the keys value from the ring's value, right? So choosing your key value to the ring. That means if you are having a ring, if you are starting from this particular position, if you are ending up this position, this will be your keys position, right? And this will be your rings position. Got it? So this particular index will define the number of min steps to reach from 2 o'clock to that particular position, and your answer lies at the last row, because that is the max length, right? So that is your max length of the string. Okay, so you can simply declare a DP table, right, which consists of ring size and the actual key size, and you can simply compute your math dot absolute difference from the left hand side, right? The left hand side difference would be len minus right hand side difference, or what, vice versa. So I'm already taking, as I told you in the intuition, we'll be taking 2 pointers, which will be the source pointer and the destination pointer, right? So check if your absolute value of source and destination pointer, let's say source pointer is S and destination pointer is D, and you will take the minimum value of this, right, every time. So len of ring minus your this particular value, let's just say this is some ST, you will take this minimum value and you will store the minimum value of your DP of I plus this particular distance, which is, let's say, min distance. And you will also add +1 because you are including that particular character. And after that, you will simply compare that with your previous result, right? So this is your total length, and you will return result, or you can return your DP of any string I. You will store this result in this DP of I, right? So let's just quickly move on to the pseudocode that I've already pre-written. So here we have the length of the ring, and M denotes the length of the key, and I'm using a one-dimensional DP array. Why? I'll be using an auxiliary array which is called next to avoid the space complexity tackling issues, right? Because I was trying to submit this using a 2D DP and I got a space limit error. So I tried using only 2, because why? This particular array, you are only taking one character of key and one character of ring, right? That simply defines us that you can take a character of key, define it with a long array, and stores the key's particular value that you computed at ith step into this particular ring, and your answer lies at this 0th row of the ring, right? So this DP will denote your ring array, and this next will denote your key array, right? You are taking your key's ith character in from the ring, okay? And this is an auxiliary pointer in the key which starts with m minus 1. So we are going from the length -1 to 0, and we are declaring a next array. This rth loop denotes our rightmost pointer, okay, which have initialized the next of r with max value because we are finding the minimum value. Okay, and ith loop will define your starting point. See, your r is starting from 0 and your I is also starting from 0, right? So if you are having a key string, we'll just say that GD, your rth pointer will be starting from here and your ith pointer will be starting from here, right? I've taken that, and as discussed in the intuition, we are going with ring is equal to k. We are computing the min distance, and the min distance is your left hand side distance and your right hand side distance. Okay, and you will store the minimum value in the next r. You'll compare your simply next r, min distance plus 1 plus dp of I. Why dp of I? Because you are deriving your value from the previous value. Means you have your GD, so you'll define the value of D from G because it came from G, right? You included your G and then you include your D, right? So this is your min distance which is being stored into your next array, and simply will copy the next array into the DP, and your answer will lie at DP of 0. Why? Because your answer will be stored in this first particular position, means your length of the key will be maximum, which is 3, and your answers ring will be also maximum, which is your length of ring, right? So your DP of 0 will be storing the max out of all the min positions, right? I mean max in the sense for the max length, not the max value, right? It will store the max length for key and as well as the bound condition for your ring. Okay, so I'll be keeping the code snippets for C++ and Java in the next upcoming slides, and you guys can have a quick look through that, and also you guys can implement this particular pseudocode on your own in your language of choice, and if not possible, please just feel free to look for the code snippets, and make sure you like and subscribe to the channel, and also keep a check out for other videos and stay tuned for upcoming videos, and thanks for watching.